I look at the answers before. I have the answers to this part. I have 0.75t plus zero point 0.2. Slightly different. The main difference in the y-intercept, but that's just a different time. All right, let's go to number 2. In a measured expression, G equals 20k minus 8, where G is measured in goats, K is kittens. Find the units of the constants. Okay? Well, this G, what type of formula is this similar to? Y equals mx plus b, right? So what is 20? 20 is the what? It is the slope. Slope is y over x, right? Now what is y? Well, y is measured in goats, and x is measured in kittens. What is the minus 8 or it's the y-intercept. That would just have units of y, which would be goats. So if you put the number of kittens in, like 3 kittens, how many goats do you get? Well, 3 kittens, 3 times 20, the kittens would cancel. You'd have 60 goats, minus the 8 goats would give you 52 goats. It's just getting you used to the units associated with the y-intercept and the slope. Okay? What was the fundamental unit of mass? Julia? Kilograms, right? Oops. So in this case, we would have kilograms for mass, right? Times length, which would be meters. And what was the fundamental unit for time? Seconds, and that's squared, so it would be seconds squared. Anyone know a shorthand for that unit? The Newton. Okay? Let's look at another one here. Let's go to a model one, okay? Next time we'll be doing some unit conversions and stuff, but now you could get started if you have time to do the internet activities. They're vector stuff, and we haven't done vector stuff yet. You'll be watching videos on it soon, but you could do those as whenever you decide. Let's look at this one though. All right, so this is 1.1 on page, this is page 9 of 14. Try that at your pace. Just give it a whirl. See if you can't set it up and solve that. I don't know if it keeps putting lines in there. So it says to create a model for a display, an astronomy teacher wants to represent our galaxy, the Milky Way, and the Andromeda Galaxy, our nearest neighbor, with dinner plates, and place them appropriate distance apart. The diameter of the galaxies are about 1 times 10 to the 5 light years. A light year is actually a distance, okay? The distance between the galaxies is 2 times 10 to the 6 light years. The diameter of the plates are 50 centimeters. How far apart should the teacher put the plates? When you think you have the answer, raise your hand. What did you come up with? 120 centimeters. I don't think that's right. Of course, the only way I would know is if I could find my work. Somewhere here. Someone have a hand up? Might be 1,000. 1,000? Might just have to redo it. All right, well, let's see. We have a plate, right? The plates are 50 centimeters across. Now, we could tell from that 50 centimeters, so this isn't only model, it says 1.1, but it's really a combination of 1.1 and 1.2 because we're going to do some conversions. We're going to do conversions with a equivalence factor, a scale. This many centimeters equals this many light years. So because the galaxies, the diameters of the galaxies are 1 times 10 to the 5 light years, we know that 50 centimeters equals 1 times 10 to the 5 light years. Okay? So now it says the distance between the two galaxies is there's such a large distance, the fact that they have distance themselves. So we'll just say center to center, okay? This distance is 2 times 10 to the 6 light years. Now we need to convert that to what for the teacher? Centimeters. So we use our conversion, the fact that the plate is 1 times 10 to the 5 light years. So we start with 2 times 10 to the 6 light years. And then we can do a fancy version of 1, like you remember from watching the video, right? If light year is on top, light year is on the bottom, and centimeters goes here. And this fancy version of 1 is going to come from this up here, from our plate. So I know this is 1 times 10 to the 5, and this is 50. Now you may have done it slightly different without doing like a conversion like that, but this works. 2 times 10 to the 6 times 50 divided by parentheses 1 times 10 to the 5th. 1,000 centimeters, which is how many meters? 10 meters. So we'd have to have like our galaxy, 10 of these things, about over, just estimating now. Here, so you'd have like a plate here and a plate way over there. Yes. Yes. You could set one, this over this equals that over that. Yeah. Okay? Good. Let's, let's try this one. Oops. A useful fact is there's about pi times 10 to the 7 seconds in 1 year. So if Emma is at a party, right, and someone asks a question, who can come up with the closest number of seconds in a year? You have, 10 seconds to figure out the problem. She could do it if she knew this. She'd be better off than somebody else who didn't know this fact, right? So it's an important fact to know. Pi times 10 to the 7 seconds. But let's find the percent difference between this value and the correct number. So we have to find the correct number of seconds in a year. So sometimes it's very helpful it's helpful to have a plan. And we're starting with year. We're going to start with 1 year. And if I just have a little plan for my units here, I would go year, right, to what? Would you go to next? Days to hours to minutes to seconds. So now I have my steps all written out for me, right? And now I draw my first closed eyeball. Homer Simpson eyeball. Does it look like that? No. I put year on the bottom, days on the top. She says 365, but what would be better? Close. What do we do at a leap year? We skip a day or add a day? We add a day, so it would be 365.25, right? If you did 365, that would have been all right too. I know, but I was thinking if you were right, and you were. So now the years cancel. We're at days. So we've gone that jump. Now we have to go days to hours. So days go down here, hours up here. What's the conversion? 24 hours in one day. Days cancel. We did that. Now we got to go days, hours to minutes. We have hours down here, minutes up here. 60 minutes in 1 hour. Now we're going to jump, whoops, minutes to seconds. A minute down here, seconds up here. And it's 60 seconds in 1 minute. And we multiply that out. Bless you. So it's all on the top. So we're in the numerator. So we don't have to all the bottoms just times 1. Okay. 365.25 times 24 times 60 times 60. Did I skip anything? Is that good? So that gives us 3.15576 times 10 to the 7 seconds. Now comes into our percent difference formula. On the front, it says percent difference, first number minus second number over first number, but that's of equal validity. In this case, this is the more exact number, so maybe I should have said percent error would have been a better word up here, and using your number minus a known number over known number. So let's write that out. But either way, it works out. So our number is pi times 10 to the 7th. The exact value, or closer to the exact, is 3.15576 times 10 to the 7. Oh, this is absolute value too. So we have the percent. Okay? So this formula you're given, but pi times 10 to the 7 minus 3.15576 times 10 to the 7 over 3.15576 times 10 to the 7 times 100. Now, when you do this on your calculator, if you don't know how to use your double E on the calculator, and you want to use times 10 raised to the, then make sure that you use parentheses around the top and around the bottom. Because what you don't want to do is have the calculator first divide that top by 3.15576, then take the whole result and multiply it by 10 to the 7. Yes. So I have parentheses, pi times 10 to the 7 minus 3.15576 times 10 to the 7, close parentheses. You should try it on your calculator if you got it, so you can do it right. Divided by 3.15576 5576 times 10 to the 7. Uh-oh. Oops. It didn't like the pi. 3.14159. All right, 3.14159 times 10 to the 7 minus 3.15576 times 10 to the 7 divided by 3.15576 times 10 to the 7 times 100, about 0.45% off. Okay? Make sure you get your chapter blocks done for tomorrow and you watch that video. Or is the video due Wednesday? That would be fine. Sure. Who else is going to the lecture? Let me know if you haven't. It's your last name dot first name and your student ID. Weird. All right. Tell me. Go to Schoology and respond to the message discussion.